we've established a system where Mesos will be communicating get set values and ping values for the emitter and the listener of the master and the agent endpoint broadcasting a heuristic or a JSON or an XML file, and we will transform these values by mutating them with digital filters. Digital filters are great at amplifying data that seems discontinuous. And this amplification gives us the ability for us to have any kind of prediction value. And outlier detection seems to be the immediate result of this, because by making the values more robust, we're able to see where are the discontinuities, where's the tailedness, where's the kurtosis, and then it's easier for us to smooth. We will do a lot of smoothing with Python as we go along in this course, and something we've seen before as well, which is finding that difference of peaks and then smoothing with a moving average. And you can actually make sense of this inside R by using Magritter, which is the piping mechanism with Caret, and DPLYR, which is the columnar matrix Latin presentation of information utilized mostly with almost all of R. Everything is pretty much a matrix. And as you can see, these are the values that we will multiply. And remember that the beauty of exploratory data analysis, and in this case, very deep learning and machine learning, is getting a set of data and extrapolating the diversity of it by mutating it with a digital filter or a moving average that can give us a sense of direction. Where is the data going? And can we make sense of that data in set of states? If it's in a streaming environment, in this case, we would be dealing with latencies of a cluster that's actually working. I would imagine a cluster that's doing anything from hosting a web service with Docker to running TensorFlow machine learning at GPU levels, bare bones, and also deploying a lot on that, on the virtual cloud, if you will. And so getting a sense of this back and forth of information, this dispatching of packets is something that can only be analyzed by exploratory data analysis. Data can be transformed as well. As you can see, you can bind this information into a vector, make an index out of it. This bundle or this index will give us a moving average or will give us a threshold. So we can see where a set of oscillators diverge and converge. Now, this is just an example. You can gather from the database, from LADDAT, a series of first differences, finite differences, norms that you can combine. You can actually find a eigen graph or an eigen matrix based on those on the raw values, and then we use ggplot, ggpair 2 inside R to see a very basic, phase diagram. I want to say a phase diagram that gives us the convergence and divergence of specific oscillators. And you can think of these as those algebraic components that when you're solving an eigenvalue problem and you're solving the eigenmatrix, you see that it's a set of values that are multiplied, be that left multiplication, to that original value that can be anything. It's not unique. because in this case, we're just outlining the distribution. And this is what we call predicting in the outlier detection paradigm, or SM binning. In this case, you can see that a box plot would give us that vertical distribution of values. You can see how they really are separated from that chip, I want to say, because that's an outlier set of values that are outside of that domain of inference for us. We struggle with the skewness of the information if it's always between -1 to 1. When we're doing machine learning, we want to map everything from -1 to 1. And we see from there on if actually a distribution is right skewed or left skewed. Ideally, we want them to be mean 0 at that saddle point. Now we have global and local outliers. Usually local outliers, like I said before, are easily found using Boxplot. This is how you carry out a Boxplot configuration using aesthetics. In this case, we're focused on the FTLM digital filter. The text will give you more information regarding these digital filters, why they were chosen. I wanted to do something related to the financial industry, to the very volatile nature of financial engineering, and I found it to be quite fitting for server maintenance, in this case for Mesos analytics. We then divide information regarding, after we transform, after we are able to get graphs from these transmutations, we can make predictions, and then we can divide them into training, into testing sets, and so on. The global identifier is actually also a distribution that seems to be Markovian